Okay, so the question is, how do we integrate from 1 to x, 2x plus y with respect to y? Well, very simple. Just as we do with partial derivatives, we look at what is varying, and what's varying is y. X is treated as a constant. Okay, so we just treat x as a constant and do the integral. So this becomes the integral, well, we just do the antiderivative. If x is a constant, then the integral of 2x with respect to y is just 2xy. Because the derivative of this with respect to y is just 2x. So this is antiderivative of this. Okay? And then, of course, we have y squared over 2, which with respect to our changing quantity y is antiderivative to y, because the derivative of this is y. Okay, so we do this, and we just substitute x and 1, and we get 2x times x plus x squared over 2, substituting x for both of the y's. And then it's minus the quantity 2x times 1 plus 1 squared over 2. And then we just do a little algebra, and we get 2x squared plus x squared over 2. That's 5/2 x squared. And check my arithmetic, it's often wrong. Minus the quantity 2x plus 1/2, right? Which is going to be minus 2x minus 1/2. Okay? Nothing to it. Now, the integrals can get harder, but the process is clear. If you're integrating an expression with respect to y, then every symbol except y is regarded as a constant. Okay, so let's try this now. And then we'll see what this means. As I say, I'd like to start with what it means, but in this course, I'll start by just doing a couple of integrals. Might not be a bad idea in other courses as well. But any other course I teach, people already have seen double integrals, so I never have to introduce it. Okay, so we're going to integrate from 1 to 4, the integral from 1 to x of 2x plus y dy. dx. Now, what do I mean by this? Take a stab.
It's just a double integral in the whole.
I'm sorry?
It's just like a double integral.
Oh, it's a double integral, yeah, but what are you going to do to evaluate this thing?
We'll do the integral in regards to dy first, and
Yeah,
then.
exactly. Okay, I figured you were going to answer that right, and I told you before, when I didn't give you a chance for glory to figure out what to do here, that I was going to give you one, right? Well, I did, and you did it. Okay, and this question's harder than that one. So, plenty of glory. Okay, now, this is what it means, and that's exactly what you said. You have an inner integral here, and your order of operation says you do that first. Okay? I'm just going to assume you understand that implicitly because apparently you do. Okay? So, in order to do this, this just becomes the integral from 1 to 4 of what you got down here, right? So it's 5/2 x squared minus 2x minus 1/2 dx. Okay? So go ahead and finish that off.